and welcome to Lesson 9 of Anatomy and Physiology. Today we're going to start a new organ system, the skeletal system. So the skeletal system is divided into two major components. You have an axial skeleton and an appendicular skeleton. And we're going to break this down even when starting to talk about the major bones of the body in our next lesson. So your axial skeleton is going to be your skull, your vertebral column, and your rib cage, and then your appendicular skeleton is going to be your shoulder girdle, your pelvic girdle, and then all the bones of your limbs. Now the skeletal system just doesn't include bones, it also includes all your joints, your cartilage, and your ligaments. And the adult skeleton is composed of 206 bones. So if we look here, this is outlining the difference between the axial and appendicular skeleton. What's in green is going to be considered the axial skeleton, and then what's the bone color is going to be your appendicular skeleton. So axial is going to be skull, vertebral column, and thoracic cage, and then the appendicular is going to be your girdles and your bones of your limbs. So what are all the functions of bones? Some of them you're going to already know, and some of them you're going to be a little surprised about. So first is support. Obviously, it's going to form kind of an internal framework. There's a episode of Family Guy that I always tell my students about where Peter's about to get punched in the face and he wishes he didn't have any bones and he's just like a glob on the floor. So it really does. It provides that kind of framework for all of your body. It also is going to protect your soft body organs. For example, the skull is going to protect the brain, your rib cage is going to protect your lungs and your heart. Movement. So skeletal muscles attach to bones, and when muscles contract, it's going to allow the bones to move. And this is kind of an important concept to understand, that bones don't actually move. The muscles are going to contract, which then pull on the bones. So really, muscles are going to be the cause of the movement. The bone is kind of just secondary. And then blood cell formation, hematopoiesis, is the correct term we use that allows marrow to create new red blood cells. We also store minerals and fat within bones. Okay, you have yellow bone marrow, which stores fat, and we store calcium and phosphorus, which are really important for nervous system contractions and muscle contractions. Okay, you remember it being a kid, your parents always told you got to drink a lot of milk because it has a lot of calcium in it and it'll make your bones nice and strong. So now we're going to talk about the different types of bones, and we're going to look at first what they're made of and then the different shapes of them. So there's two basic types of bones. You have compact and spongy. Compact is normally going to be found on the outside of bones, and it's really hard and smooth. And then more internally is going to be spongy bone, and it sounds exactly what it looks like. It kind of does look like a sponge. And then we look at bone shapes. So long bones are going to be your typical bones of the limbs. So if you look at your femur, which is your thigh bone, or your humerus, which is your upper arm bone, those are all going to be examples of long bones. Then we have short bones. These are going to be cube-shaped. These are going to be your ankle, your wrist, and your patella. And patella is going to be your kneecap. Flat bones are going to be your skull, your rib, your sternum, and basically they're just going to be thin layers of compact bone that sandwiches a layer of spongy bone. And then irregular bones don't fit into any of the categories above, and a great example of that is going to be the vertebrae of your back. So if we look, here's our typical long bone, which would be like our humerus and our femur, our ulna, our radius. Okay, then we have short bones or cube bones, sometimes you'll hear them called. That's going to be wrist, ankle, patella. Okay, there's your kneecap right there. Flat bones, sternum, bones of your skull, and then irregular bones don't fit into any of those other categories, and a great one is going to be an example of your vertebrae. So now we're going to get into the microscopic structure of bones. So first we're going to look at our gross anatomy, and then we're going to get into our microscopic anatomy. So these are just important terms, and we're going to look at the anatomy of a long bone. So first, let's look at that long bone. The diaphysis right here is known as the shaft of the bone. So this is what's going to make up your bone's length. And it has a really tough connective tissue covering called the periosteum, which is secured down on the bone by what's called Sharpie's fibers. And they really are. They kind of look like little needles almost sticking out that are really taking that connective tissue covering and laying it on top of the diaphysis. Okay, the end of our long bones are known as the epiphysis. And this is going to be compact bone, and then on the inside is going to be lots and lots of spongy bone. The very end of the epiphysis is going to have a layer of cartilage called articular cartilage made of hyaline cartilage. This is the kind of cartilage that breaks down when people start to get arthritis. It's because that articular cartilage on the end is starting to break down, and when you have bone-on-bone friction, it becomes very painful. So this hyaline articular cartilage is really important for maintaining healthy joints. Then you have an epiphyseal plate. We've all heard of our growing plate or our growth plate. This is hyaline cartilage that eventually is going to turn into bone as we grow into adults. You also have red and yellow marrow. So yellow marrow is going to be more found in the diaphysis portion, and this is where we store a lot of fat. When you're very young, though, it's going to be red marrow because you're producing a lot more red blood cells. And then on the end of our bones and our epiphysis is where you're going to find a lot of the red bone marrow. So let's go ahead and take a look at a whole here of everything that we've talked about. So here's your epiphysis. You have a distal and a proximal one. That's where you're going to have your articular cartilage on the outside. So this is your articular cartilage. Okay. You're going to have a layer of compact bone and then spongy bone here, which is going to have a lot of red marrow in it. Your epiphyseal line is going to be the epiphyseal plate if you're growing. That's your growth plate. Here's your diaphysis. Okay, the shaft. Inside here, you're going to have the cavity holding your yellow marrow. Okay, so now we get to talk about the microscopic structure. So osteocytes are mature bone cells. So once your bones have grown and these cells are kind of done building or breaking it down, they house themselves in these little tiny cavities in your bone called lacunae. And these lacunae are arranged in circles called lamellae. And they really kind of look like if you were going to cut down a tree. You know, when you cut down a tree and you look at it from the top, there's a bunch of rings. That's really what these lamellae look like. And inside those lamellae and lacunae are little osteocytes. In the middle of those circles, you have what's called a central or Haversian canal. And that's going to be where all of your blood vessels and nerves can innervate and basically provide nutrients for these osteocytes or these mature bone cells. All of these things together are going to create what's called an osteon. And an osteon is a really important term because that is basically the structural unit of bone. So if we look here, this would be one osteon, okay? One osteon. See, when you look at it really close up, you can see there's nice rings. It looks like if you cut a tree down. And if we zoom in, okay, zoom in here, here's your osteocytes, your cells, and they sit in little cavities called lacunae. And these lacunae are arranged in those circles called lamellae. So you can really see how that's kind of set up. And then here is that central canal where this one is showing that you have blood innervating it. So central canals are going to run lengthwise through the bony matrix and carry blood and nerves to all of your bone. But you also have these other canals that are kind of cool. So you have canaliculi, which are going to radiate kind of outwards from the central canals to all the lacunae. So this is really your transportation system that's providing all these little blood vessels going towards your osteocytes and your bone matrix. And then you have Volkmann's canals. These are going to kind of run from the outside of the bone to the interior. So this is what's allowing blood vessels to actually go into the bone. So if we look here, here would be an example of a Volkmann's canal. So anytime you see these that are going to kind of basically go out of the bone, those are going to be your Volkmann's canal. All right, so now we get to talk about formation, growth, and remodeling. So when you are in the womb and you are developing, you don't have bones yet. You actually have hyaline cartilage that bone is going to be laid on top of, and this is called ossification. So first you have these cells called osteoblasts, which are bone-making cells. They're going to come and lay down bone matrix over the hyaline cartilage. Then the hyaline cartilage starts to get digested away, opening up a cavity for your marrow, and that's how your bones are really created. So you start out as cartilage, and then you just start laying bone down on top of this cartilage. And as these osteoblasts are laying more and more bone down, we start to get innervation from blood vessels and nerves. So then by the time you are a child, the only cartilage really left are right here, your growth plates, those epiphyseal plates. But it's just really important to understand that at first, you are mostly hyaline cartilage. And then as you are developing and growing, you're laying down bone on top of that cartilage. And really, you're releasing hormones that are allowing this to do this and are stimulating those bone cells to really start making new bone. And then by the time you are late into high school, especially for girls, you're done growing and you have no more bone, or no more cartilage, sorry, you obviously have bone. So remember that bone is a storehouse for calcium. When calcium levels actually drop too low in your blood, you have a specific cell called osteoclasts that are going to destroy the bone matrix to release calcium in your blood. And then vice versa, when calcium levels are too high, osteoblasts are going to come and deposit that calcium as bone matrix on your bones. So really, this is how we control blood calcium levels, is by these two different cells. All right, bone remodeling. This is really essential when you're going through growth spurts, or even if you have a slight fracture. Basically, you're going to lay down new bone matrix, and then once those osteoblasts lay down that new bone matrix, they get trapped inside and become osteocytes in their little lacunae. Fractures. We're going to actually listen to a podcast on fractures later on in a few lessons, but we know that fractures are when bones break. So if it's a simple or closed fracture, this means that it has not penetrated out of the skin. And when the bone ends do go out of the skin, it's called a open or compound fracture. So when you break a bone, you're going to go into the doctor, and the doctor is going to do something called reduction. And this just means that they're going to put the bone back to where it should be, and then they're going to cast it. And here are just some different types of fractures. And like I said, we're really going to get into all of these different types when we listen to a really cool podcast about it. So we're going to talk about bone healing next. I'm going to go ahead and stop the video here so I don't go over on time, but we're going to pick back up here on video 2 and talk about what happens when you do have a fracture. How do your bones heal?